Hi everyone, I'm Zhen Xie, and just right now the Huiho and Corey present perfect tutorials on Harvard and DDP, and you learning the Harvard and the DDP store all of the activation and the parameters on each GPU, and so based on that, they can work well when the deep learning model is pretty small, but if the deep learning model is pretty large and of the parameters and the activation cannot be stored on one single node, so there will be an out of memory errors. So based on these scenarios, and the Microsoft proposed a framework called DeepSpeed, and this is a new framework, and it also is a open source framework focused on optimizing the training of the large deep learning model. So from let me open my video, and
could you also switch to presentation mode?
Yes, I think it's
or reading mode.
Because I have two screens, so it's very hard to share the screen. So
it's okay. It's okay.
I can do it larger, and yeah. So it works.
Yeah. Thank you.
Okay. So the DeepSpeed is a new open source frameworks focused on optimizing the training of large deep learning models, and from the programming standpoint, the DeepSpeed is built on top of the PyTorch and provide a very simple and easy API that allow the engineer to leverage the parallelisms techniques with just a few line of code changes. And the DeepSpeed abstracts of the difficult aspect of the large-scale training, such as parallelization and the mixed-precision and the checkpoint, and allow developers to focus on the construction of the models. So as we can see here, the DeepSpeed extract a lot of contributions and stars and forks, and this framework is become more and more popular. And the deep scale framework has 4 key advantages. The first one is the scale. The DeepSpeed can provide system support to up to 100 billion parameters on current cluster, and it also can show 4 times to 5 times higher throughput than the other library if the model is pretty large, and the cost is 3 times less than others library, and the usability is that it does not require to refactor the PyTorch models and just use a few lines of code changes to use this framework. And so based on that, we are trying to explore we are trying to deploy the DeepSpeed and explore the DeepSpeed on Theta GPU, and this is the path of the. So we test one example on Theta GPU. This is the path of this example. So we tested under Theta CFA dataset on CM model, and this is the code we run on single GPU on single node, and it has 2 parts. The first step is to set up the environment. So we create a conda environment based on this file, and to activate this conda environment. And then the second step is go to this path and run this code. And this code is based on the host file and the Python file and the configurations, some configurations. So I will show it later. And after that, if you can get a result from if you can get a result like this one, and you can successfully run this code. And we also have some future plans on this framework, because this framework is pretty new, and we just begin to explore this framework. And currently we successfully tested one case with Theta 10, and after that we will test more cases such as Megatron LM, one cycle, and the BERT model. Those models are pretty huge, and we'll also will do more test cases on multiple loads, and to verify the correctness. And after that, we will compare the performance with Harvard and the DDP, and to compare with which one is best. And let me show the codes. Yeah. If you have any question, please be free to stop me at any time. And, so we can download from our GitHub repo, and this is the code. There we can see two files on this path. The first one is the PyTorch, the Python file, and the second one is the configuration file. And we will see the Python file first. And the first step is to import the DeepSpeed package, and those are some parameters in terms of the training, how many GPU do you want to use, and what is the batch sizes, and how many epochs you want to train. And after that, you want to initialize the DeepSpeed, such as MPI and some other frameworks. And after that, you want to get the rank to set a barrier to synchronize with other MPI process. And also we can get the data set from here, get the Theta 10 data from here, and build the data loader from here. And after that, we will define the CNN model, and in this CNN model, we need to use some interface in the DeepSpeed, such like we need to initialization the DeepSpeed, and use some interface, such like here. So like here, we need to use some interface of the DeepSpeed, and to make often this happens on DeepSpeed. And after that, after the network is created, we can set the optimizer initialization, and also we can enable the half precision and the full precision. And after that, we can train this model, and this train model is go to the backward and the forward path, and update the parameters. And finally, we can get the result here. And the second file is the configuration, and we can show here. The second, it includes the batch sizes, steps, and optimizers, and also it includes the mix precision and the checkpoint configurations. So and also they can set up or reduce and or gathers to make the memory consumption pretty slow, because the traditional framework will store all of the parameters on each GPU or each load, but this framework will store part of the parameters and the activations on each GPU. So if the one GPU want to use the data on another GPU, they will use the broadcast to get the data from another GPU, and then they can use the all reduce to have the final gradients. And okay, after that, I will show how to run this code. And on this GitHub repo, we have one examples, the zeta 10 on CNN, and you see there are some script here that we can use only any one of them to run the DeepSpeed with zeta 10 on single load, multiple load, and single GPU, multiple GPU. And I will run single GPU fast. And the first step is to set up the environment. You need to install the DeepSpeed and need to install some packages. And then the second step is to run the code on the PyTorch, but Python file. And then it will be a little bit time consuming. We can wait a moment. So this paper will detect how many GPU do you have, and they will launch the training. And we can say they detect one GPU and launch the DeepSpeed training here and enable the half precision to and after that they will run a real training, and the training is finished, and then they will get an output here. You will get an accuracy or something. Yeah, and so based on this, so in conclusion, based on this framework, we can run more larger deep learning models such as BERT and the state of the art. So based on that, we can run more larger models such as this model, BERT model, and the one cycle model. The model is pretty large and they have so many parameters. So, and we can use small and less GPUs to run large models. So this is the advantages of this framework. And after that, we will submit all the tests to the GitHub, and we also will propose the performance comparison with the Harvard and the DTP to the GitHub repo. Yeah, this is often the content with this framework.
So we'll add some language model example, because I don't think any of the SDL examples do any language modeling, and that's a important part of machine learning these days, that the scientific applications that we should add.
Yeah, sure. we should add a BERT model, because the BERT model can be run on multiple GPU with Harvard, but we can compare the performance with Harvard also. Yeah, and we can also add this model to our GitHub. Yes, currently we are trying to explore this new framework, and also we will get more results of this model with this framework later. Yeah.
Thanks. Any questions for Jim?